Yeah. Okay.
Madam, 1 minute, 1 minute. Sir, shall we start, sir? Anjaneyulu, sir. Hello.
Yeah, we can. Can you hear me?
Yes, sir. Yes, sir.
Okay. Shall I start, sir?
Yeah, you can.
Yes. Yes, sir. Okay. Welcome all to the session 2 of the online FTP. We are delighted to have you all here today. And in this session, we are honored to have Dr. L. Anjaneyulu, sir, Professor, Department of ECE, NIT Warangal, as a distinguished speaker. Let me now take this opportunity to introduce the speaker of session 2. Dr. L. Anjaneyulu is currently a senior professor of Department of Electronics at NIT Warangal. Professor L. Anjaneyulu did his MTech from Department of Electronics and Communication Engineering, REC Warangal, in 1991 and later did his PhD from NIT Warangal in the area of radar signal processing. During 1991 to 1995, he worked as project officer for Institute of Armament Technology, DRDO, Pune. Now it is DIA, Defense Institute of Advanced Technology, and involved in the surface-borne and airborne radar development for military applications. Later, during 1995 to 1997, he worked as a senior staff scientist at Helios Software Systems, Madras, and involved in the development and deployment of strategic software for the performance assessment of onboard fire control and missile guidance systems of Indian Navy's warships under Indian Navy Technical Evaluation Group, INTEG projects. After spending 7 years in defense research, he joined back NIT Warangal in 1997 as a regular faculty in EC department and served as the head of the Department of ECE. Currently heading 2 centers of excellences on drones, robotics and autonomous vehicles, and virtual reality, augmented reality for digital manufacturing. Currently, he is also the head of Center of Innovation and Incubation and Intellectual Property Rights Cell. He is also the principal investigator of Capacity Building for Design and Entrepreneurship program of Ministry of Education Initiative. He has executed research projects from Defense Ministry, DRDO, ISRO, and also projects on development of virtual reality and mixed reality systems from Ministry of Mines. Currently executing 2 projects from ISRO using Chandrayaan-2 and Chandrayaan-3 data and 1 DRDO project. His areas of interest are computer networks, artificial neural networks, and fuzzy systems, microwaves and antennas, electromagnetic field theory, radar signal processing, and communications. During his service of last 28 years at NIT Warangal, he served in various administrative roles such as professor in charge of Center of Innovation and Incubation, IPR cell, in charge of Internet and Telecom, member of Institute Master Plan Committee, nodal officer of NKN Network, etc. Currently, he is the nodal officer of Rashtriya Avishkar Abhiyan and principal investigator of science communication, popularization and extension scope of Vignan Prasar under the Department of Science and Technology. He was involved in the training programs conducted for Telangana school teachers, sponsored by SCRT under a project on mentoring and handholding of school education system in northern Telangana through Rashtriya Avishkar Abhiyan. He led several community service initiatives on ICT tools education for the rural youth. police personnel and police personnel and rural girl students, etc. Currently, he is also professor in charge of engineering projects in community services, EPICS projects and innovation garage. He is a senior member of IEEE, member of IEEE Antennas and Propagation Society, Signal Processing Society. He is a fellow of Institute of Engineers, fellow of IETA, life member of ISTE, a member of International Association of Engineers, and member of Design Society UK. He has guided 7 PhD students and currently guiding 12 PhD students and 2 postdoctorals in these areas. Antenna design for wearable and future wireless applications, synthetic aperture radar image processing, underwater communications, etc. He has published about 40 papers in international journals and about 50 papers in international conferences. He is a popular speaker on science and technology related topics and a motivational speaker among school and college education circles. He is a winner of IET Gold Medal Research Award along with a colleague. He has visited and has international academic relations with University of Malaysia, Perlis, Khalifa University, Abu Dhabi. Dr. Anjaneyulu sir will be delivering an insightful talk on the latest developments and future directions in V2X communication, V2X communication beyond 5G. We look forward to an engaging and informative sessions. We request all the participants to actively engage and take maximum benefit from this insightful session. Let's make the most of this wonderful learning opportunity. Thank you. Over to sir.
Okay.
Sir, you can share the PPT now, sir.
Yeah, I can share. So I think the video is disabled. I'll just share the slides only. Okay.
Yeah, sir.
Can you see my screen, please?
Yeah, it's visible, sir. Yeah.
Okay. Yeah, just a second. Yeah. So thank you. Thank you, Vijayati, for inviting me for today's talk on 5G and beyond for intelligent transportation. I think looking at the schedule that you have given for all the 6 days, so it's wonderfully planned and all the topics are very relevant for the theme of the workshop or for the theme of the faculty development program. In fact, I think today's session should have been swapped as per the titles. But somehow, anyway, this 5G and beyond for intelligent should have been first session, and then I think the talk by Professor Dubey, Ankit Dubey, should have been the second session because that's more technical. This is only an introductory part. But anyway, nevertheless, I'll try to give you some, insights into the topic that is being given to me as of now. Okay, so thank you all. Maybe I'll be talking for next 60 minutes or so. Followed by maybe we'll have some interactive session if time permits. Okay. So this is the outline of my talk. I'll start with a brief introduction to what is the connectivity in future is all about and how it is actually making a leap forward changes and technological changes that are taking place into the connectivity, the issues. I mean, the meaning of connectivity itself is changing as we go into the future, and followed by understanding some of the features of 5G. Then I'll take up a 10-minute session on 5G enabled intelligent transportation systems, and then what are the core applications, followed by IoT and data integration. Then beyond 5G, what 6G promises. and what are the societal and economic implications of the technologies, and then the challenges and considerations, and some global case studies, and then future path and conclusions. So these are actually I planned because this session, as to the title given to me, it should be an introductory lecture without much of technical detail. That's what I understood. That was the title given to me in the beginning, but later on, I think the schedule has been changed and included V2X. Earlier, I had seen only introduction to some communication technology. Based on that, actually, I prepared the. It doesn't matter. I'll try to, make it. I'll try to bridge the gap, and then let's see how it goes. All right. So, looking into the future of connectivity, as we all know that we have the fourth industrial revolution and mobility. After Industry 3.0, now we have the fourth industrial revolution, which essentially talks about the convergence of various technologies, let it be AI or IoT, automation, and then big data analytics, and so on and so forth. So basically, these technologies now dictate the future, and they decide, they transform the society and industry. Unless we see another big leap, but as of now, Industry 4.0, 4.0 is actually a combination of the advanced technologies by which we have, we have all kinds of applications and all kinds of services that are automated. So, especially in the context of course, AI has actually strongly impacted all walks of life, from very common routine tasks to the complicated industrial processes. Okay, and if you see Internet of Things and then automation, then there are tremendous developments have happened. But since we are trying to understand the impact of fourth industrial revolution on the mobility, in the context of mobility, if you see the trend, or if you see the shift from traditional transportation systems to more intelligent, interconnected, and automated networks. We do have systems already running and working in terms of various contexts. Okay, let it be transportation on road, or let it be transportation on water, or transportation air, whatever it is. All kinds of traditional transport systems now have been replaced after the fourth industrial revolution, which are more intelligent, interconnected, and automated. So therefore, actually, there's much to talk about these three adjectives or verbs that I'm showing on the screen. That the meaning of the intelligent system, or the meaning of interconnected systems, or the meaning of automated networks is not actually fixed. As we go into the future, more and more, more and more technicalities are added, and then more intelligence is into the systems architecture. Okay, so that way, we can understand the futuristic mobility systems with all these abilities like intelligence, interconnected, and automated, and that's what we see in the real world. But for this to happen, for you to have an intelligent system, interconnected or automated, we need basically very large communication bandwidth. Not only bandwidth, because bandwidth is not an issue as of now, because we have utilized the complete electromagnetic spectrum for various applications, and even toward the higher end of the electromagnetic spectrum, in terms of several gigahertz, we have enough bandwidth, and in fact, we have more than the required bandwidth. It's only up to us how efficiently we use the bandwidth available at higher bands. Okay, so because of the simple reason that whenever you wanted higher bandwidth, we have to shift to the higher bands, and not only the bandwidth, required bandwidth in terms of maybe thousands of megahertz or gigahertz. I'm talking about bandwidth, not the carrier frequency. Apart from this, we also need very high reliable systems. And in addition to this, we need to have kind of a low latency communication, where low latency means that the time delay should be of the order of if possible, of the order of, a fraction of milliseconds. Okay. And this capability, as we see as on today, which is already there in place, which has a widespread market over the entire world, by which we can see it's the only capability that is enabled by the 5th generation communication system, or 5G. Okay, only 5G can give you this kind of intelligent, interconnected, and automated networks because of their features like high bandwidth, ultra reliable, and low latency communication. And now, as we know that we already have 5G phones in our hand, and then we are actually, enjoying the 5G services, of course, at a fraction of a second, depending on the network latencies. Okay. So therefore, when you apply this kind of a network for the, moving in entities, okay, where your mobility is also evolving towards a seamless integration of autonomous vehicles, real-time logistics. It is because of the high bandwidth and ultra reliability and then low latency. Okay, it was possible to have autonomous vehicles, use with an integration of AI and Internet of Things and other automation. Okay, where we do not need a person to drive a vehicle, but it kind of a self-driving mechanism, has. So it is because of these capabilities, it is possible to have autonomous vehicles, okay, on the road, and it is also to have a real-time logistics, okay, because there is an ultra-low latency network supporting, and also smart city infrastructure. And as you see carefully here, that it actually impacts how people live and people move, and then how the business takes place, and how the sustainability aspects are addressed. So therefore, this entire technologies, when you integrate all of them, ultimately we have a new world. Okay, we have a new interconnected world. Okay, where everything happens in a fraction of a second. Okay, and that's what actually we want to discuss today, specifically how 5G influences the intelligent transportation. I mean, my job is that though 5G can do lot many things, but my job is to give you more information on how transportation has become intelligent with 5G and beyond 5G technologies. Okay. So, I mean, this was just a summary of what I just spoke, Industry 4.0 and the mobility integration, okay, with all these 3 technologies, with the smart vehicles, and, and then the connectivity together. Okay, but just to understand why intelligent transportation matters now, why is it required? Okay, why we need to put in intelligence into the transportation? Everything is working fine now. But what is the advantage that we get if you make the transportation systems more intelligent? Okay, so we have to see some requirements, and then I mean, if you know the requirements accordingly, we can address through the applied research in 5G whether the 5G can solve that requirements. Because see, any research starts with understanding the pain, understanding pain of the people. Okay. So the pain of the people can be expressed in terms of the suitable problem statement, and if not pain, if not painful issues of people on society, but it can be better living. We have better living standards as suitable to the current urban life. Okay, so therefore, to understand why such an intelligent transportation matters and why we need it, it is because of the rapid urbanization and people moving to more and more to urban for work or for whatever. And then we have the United Nations sustainability goals where we need to achieve down the line by 2030 or 2040. Okay, and also the aspects of safety during travel and efficient transportation mechanisms. So all such things. So there are some of the things why these things actually demand the kind of an intelligent transportation system. Okay. And also, more specifically, if you have intelligent transportation, it will definitely address the kind of a congestion and pollution in the cities. Because as we seen in the previous slide, that we have an artificial intelligence and then IoT, okay, are all integrated into the smart city infrastructure. So therefore, it is possible that transportation can be directly or directly linked to the pollution, because traditional transportation creates a lot of pollution. So therefore, if to pollution-less transport vehicles like EV, electric vehicles, or electronic vehicles, whatever, so the pollution can be cut down. Okay, so therefore, intelligent transportation can reduce your pollution impact, and also the congestion can be avoided because now intelligent planning of routes can be done. And the routes can be adapted. So therefore, congestion can be controlled. So this is one concern which intelligent transport systems ITS can definitely address, and it is possible. And we are seeing in reality how it is happening in advanced or developed countries. Okay. The second requirement is demand for real-time information by drivers and passengers. Okay. This is another requirement why we need intelligent transportation. Okay, so real-time information by drivers means maybe for various, requirements of their own, to understand when, when a particular vehicle. Hello, sorry. Can you mute, please? Yeah. So we have a demand for the real-time information of the drivers as well as passengers. For passengers also, while on the travel, they would like to have information at what time the vehicle that they're looking for will reach their place for boarding, or at what time they'll be reaching approximately, for various reasons. So they need real-time information both by drivers and passengers. This is one of the requirements. Similarly, integration of electric, shared, and autonomous vehicles is another requirement. Okay, because of the urban lifestyle, and people would like to even work while traveling to office. Otherwise they have to drive on their own. But if they travel in autonomous vehicle with a route pre-programmed, and then possibly they can even work while traveling, or maybe they can watch a high definition movie while traveling, whatever. For various reasons, we need integration of some of these technologies to suit the fast life people. And another important requirement is mobility as a service model. Okay, like software as a service. Similarly, there are various models that we are trying to come out with. Even mobility also can be offered as a service. It is called MASS, mobility as a service model. I'll just maybe cover a few aspects later. But this is another requirements which ITS, intelligent transport system, can address. Okay. So therefore, all these requirements can be met by the 5G technology in terms of having a massive connectivity among devices in real time. Okay, and then the decision making also can happen for the required applications. So effectively, the travel time can be reduced, commuting time can be reduced, and then the pollution can be reduced, and overall the quality of life, urban life, can be improved. Okay, this is the reason why we need intelligent transportation systems. They're already there now in the market, but we need more and more facilities. Okay, so this is a just slight summary of why, if you just see here that in the current situation, a user has to deal with, various transportation mechanisms by various ways. But whereas if you have a technology with mobility as a service, and through which they can manage all kinds of their, travel or mobility requirements. Okay. So as we see, again, I'm talking about the fundamental future connectivity requirements. As we see that we have the communication has evolved from 1G to 5G. Anyway, I will not go into the fundamentals of 1G, 2G, 3G, not required. But our interest is to understand more on the aspects of 5G. So 5G is not a technology where everything happens fast in split of a second or in fraction of a second. But we see all kind. I mean, we see an entirely different kinds of services that are offered for various requirements of the people, from mobility to all kinds of services. But if you see the mobility in terms of autonomous vehicles and then traffic management and then road safety management, etc. Okay, and of course 6G is which is expected maybe next few years, supposed to improve it much more in terms of some of these essential requirements. So on the screen you see how the system has evolved from 1G to 5G, with data rates going up from few gigabits per second to tens of gigabits per second, and then requirements from basic analog services to low latency fast speed services. Okay, a simple snapshot showing you the roadmap. It's not really roadmap. The history of evolution of the systems. Okay, so now just to see the role of 5G to act as a transformational backbone for this entire thing to happen, is actually it powers the smart and then connected mobility revolution, supposed to contribute in terms of, as mentioned earlier, but little more finer details are given here, in terms of ultra reliable low latency communication, and then supporting millions of sensors, and then which are integrated into various systems. They can be vehicles or roadside devices, okay, which can be operating in tandem, or they can be operating independently, whatever it is. Okay, and then possible to have the data and the video to be transmitted at a faster speeds in a high bandwidth link. Okay, so therefore now 5G, because we want to talk about 5G and its 5G and beyond for intelligent transport. Now with these features, now 5G can empower serious industry operators, service providers, so that we'll have a safer, smarter, and more sustainable mobility solutions. We only have to look into the future and how it impacts in various fields. Some of them I will cite in some of the lectures. Okay, so that's the first aspect I thought I'll talk on to the future of connectivity. Now, just to understand more aspects of 5G, as I mentioned earlier, that with 5G it is now possible to reach speeds up to 20 gigabits per second, and then where download speeds also can vary. But of course, we have the international regulations for various countries depending on the respective regulations. Some of these speeds might vary for their own reasons, as per the International Telecommunication Union regulations and other standards of 5G. Okay, but anyway, now we have 5G NR, new radio regulations, 5G NR taking place, and then as per that it goes. And then coming to the latency, it's only a few milliseconds that we have in 5G, and with less round trip times, and also for typical automotive and vehicle to anything communication is possible because of this low latency. And of course, as far as transportation is concerned, it is possible now to integrate millions of devices within a less distance, because essentially all these new technologies, we don't need very huge base stations like the previous generation like 2G and 3G. Okay. In 5G, we will have very small base stations, which are typically mounted on the roadside, poles or roadside installations, which actually, radiate very less power. Okay. I mean, that's the only reason why the 5G requires, less power. So, and hence your battery life is more. Essentially, you don't have to spend that much of your, power. All right. In terms of the communication technologies with MIMO, etc., and as well as the base station or the transceiver being very close to the receiver. Okay. Unlike in the previous systems where the distance between you and the base station earlier it used to be maybe a few kilometers, 3G or 2G base station. Okay, but once 4G and 5G are in place now, the distance between you and the nearest 4G or 5G transceiver is only few, maybe max of few hundreds of meters. So it's not necessary that you have to radiate that much of power for communication, and hence the efficiency also now increases because of the low power requirement, and your battery life also increases. Whatever. So therefore, these are some of the essential things. This is a snapshot of the main features of 5G network, which I've described previously, with some numbers given here, typical numbers given, how many devices it supports and what is the typical throughput and distance. I mean, the mobility, speed, and then efficiency, reliability. Okay, and then data volume of tens of terabytes, and then latency. Okay. So apart from these features of 5G inherent basic features, we do have some of the other technology advancements inherent into the system. One is millimeter wave bands that are used by the 5G systems. So therefore, you have a lot of bandwidth available. The moment you say millimeter wave, okay, typically you're talking about tens of gigahertz as a carrier, and then so therefore you have enough bandwidth, okay, to accommodate several video and audio channels and data channels. Okay, that's the advantage. But of course, the effective range is a bit lower, and as we mentioned, that since it's going to have a massive connectivity between the devices which are close to each other, we don't need to deal with large distance and more powers. Okay. So therefore, shorter effective range is not an issue in 5G, but in fact, it is good that we have less, error, less BERs, bit error rates, because the range is not, very high. And similarly, apart from this, we do have technologies like massive MIMO, okay, where we have a large number of antennas deployed so that the throughput and spectral efficient reliability can be improved. And apart from this, these networks are also organized as small cells. Unlike in the previous generations, we have each cell is equivalent to a few square kilometers. But now, as I mentioned earlier, we can have low power base stations, so that whatever issues that we'll have with the propagation delays or propagation loss due to over the range now can be minimized. Okay, and also the losses due to any obstacles like massive buildings now, all that. And apart from this, there are also other communication technologies which actually help the communication to happen without any issues like intelligent reflecting surface and things like that. There are so many other supporting technologies for 5G which can be integrated with mobility intelligent mobile transport systems. Okay, apart from meeting other communication needs like for audio, video, or voice or whatever. Okay, so therefore organizing small cells, they are a dense deployment, can avoid some of these challenges. Okay. Especially as I mentioned, when there are obstacles like in tunnels or intersections. okay, where there is a 90-degree, intersection where vehicles have to move, or when vehicles are need to communicate. I think I have a infographic I can show you. So essentially now, with 5G, it is possible to have very intelligent transportation, smart traffic management, public safety can be ensured, and smart city lighting can be managed, green energy aspects can be met, and ultimately we do have smart cities, and then precision agriculture, farming automation, remote monitoring. Okay. Similarly, precision healthcare, patient monitoring, telehealth, industrial IoT, all these are actually capabilities of 5G. Okay. They're all possible only because of these features of 5G that we are talking about. Okay. Essentially, energy efficiency, reliability, ultra reliability, and low latency, and then the amount of data volume and then peak rates. These are the essential things by which it is possible to have such a wonderful services. Okay, possible, and now we are actually enjoying. Okay, so apart from this, we do have other cutting edge technologies like edge computing and its role in 5G. Okay, where edge computing comes. Okay. So now edge computing is possible, as I mentioned earlier, that wherever data is generated, the computation resources also can be there. We need not transport the data to over large distances. We can process then and there itself. Okay. So therefore, such thing is now called an edge computing because we have the resources available at the same place. Okay. So therefore, it is possible to have such computing resources near the base station or roadside units because of this technology. So since we need to transport data over longer distances, obviously we'll have very less latency, and therefore data processing can happen very fast. Okay, and some of the time-sensitive transportation tasks like collision avoidance, and real-time navigation, autonomous driving. Okay, they all can be handled very easily. Okay, now you see here the low latency and the reliability and the amount of data processing capability now can actually work in terms of several real-time applications as shown here. Okay, because they're all the current requirements. Okay, so therefore they're all interlinked. What I mean to say is that all these things are interlinked, and with this interlinked thing, it is possible for us to come up with so many requirements met by proper designing of the systems. Okay, all right. So this is a very crucial, what do you say, a very critical aspect of maintaining a 5G ecosystem. Which actually was not available earlier in 3G and 4G. We had to move data to some, through cloud resources to some places like data centers where processing used to happen. Okay, but now that is not necessary here. Okay, that's not necessary. We can have the entire computation taking place right at the place where data is generated. Okay, to give you an example to you, what I'm trying to tell you, is to measure the traffic density, or to have vehicle-to-vehicle communication, or to give information about the upcoming traffic jam to a driver at this point itself. So all these roadside units have the enough computing capability to process and then give the statistics to the drivers. I mean, it all boils down to this. And that's what actually we mean by the capability of all these IoT, industrial IoT sensors with 5G technology integrated. Okay. So therefore, essentially, what we have now, we have a robust support, and then also connectivity management can be done, and then it can be adapted to dynamic network conditions and vehicle mobility. Okay, dynamic network conditions means like using a right routing protocol, or using the best routing protocol, or adapting to the mobility conditions, like when there are traffic jams or accidents. Okay, so usually the mobility get affected. So accordingly, this technology can manage those things. So as I mentioned earlier, all these things are very interlinked, and then it is possible to have several services. Then apart from this, there is also a kind of a feature called network slicing. Okay? Network slicing as part of 5G architecture. Now, how network slicing can help to make transportation more, or how we can use it in transport applications. Okay. See, network slicing essentially means that to dedicate, virtual sessions for various things. Okay. So it is possible to, create virtual and isolated slices of physical 5G network. Okay. It is possible to segregate, or it is possible to dynamically organize the network architecture in such a way that we can meet the requirements of the users or customers. Okay. So that means we can have a dedicated network resource working for a particular set of users, a particular set of end users. Okay. So it is because of this, this is technically called network slicing. Okay, instead of dedicating the entire source to destination route for a given for a given application, like only data, only voice, or only audio, or only kind of thing, it is possible to streamline some of these things by using network slicing technique. Okay. And with this kind of a network slicing, now it is possible to have a very low latency and high bandwidth and security, and also support for autonomous fleets. Autonomous fleets means the vehicles, a group of vehicles, moving from one place to another place, carrying, various goods and services. Similarly, smart traffic lights, and then accident reporting, fleet management. So these are all the very high-end requirements which are now met through the 5G technologies. So this entire support system can be part of your smart city, architecture, depending on how it is seen. Okay, and then it is possible to have multiple services like emergency vehicles and public transit can share infrastructure but remain independent. Okay, for example, emergency vehicles need to be addressed immediately, whereas public transit now can be held for some time. Okay, so therefore, in such case, how the infrastructure sharing happens, both physically and then electronically. Now that can be handled using this one. Okay, again, this is a simple comparison of 4G and 5G, and the current 5G, and then what the previous 4G has offered as far as automotive or automation is concerned. So if you see here, the peak speeds have increased from few gigabits per second to tens of gigabits per second. So now it is possible to have a real-time high definition maps, and also we have over-the-air fast OT updates, over-the-air updates. And this is the impact on transportation. Okay, when 5G and a new regulation, a new radio regulation came into picture. Then similarly, due to latency, we have a safer collision avoidance, V2V and then V2X systems possible. Similar device density, okay, massive IoT vehicle sensors now can be integrated, okay, in 5G because we have 1 million per square kilometer. Similar reliability, now from high to ultra reliability, 99.99. So therefore, some of the critical applications like autonomous driving and mission critical applications typically used by the military or any other thing, now it helps. So these are just comparison. Okay. So therefore, as far as our intelligent transport systems are concerned, that is now possible to have vehicle to vehicle, and then vehicle to infrastructure, and then vehicle to person or a pedestrian possible. Okay. Anyway, I'll not go into more technical architectures of this. That's why I was telling you this could have been addressed by the, it's supposed to be addressed later after my talk, but it doesn't matter. Yeah. So this is another aspect on 5G, understanding more about 5G. Now to see the third aspect of 5G enabled intelligent transport system, what we have, how it is possible, and then what are the key components of intelligent transportation system. Now, if you see the key components are IoT, the sensors, AI, and robot communication network, and then the main components. Okay, one is infrastructure, and then we have the onboard vehicle sensors and corresponding diagnostics, and then centralized control center. So these are the key components of intelligent transportation system. Okay, so now we have to understand some of the aspects by which these things can be used. Okay, so typically the intelligent transport system consists of the basic, as shown in the previous slide, that all this actually is part of it. So your traffic management center should be able to take care of the data flow between the centralized system and to all other nodes. Okay, to communication network, and then to the traveler, to the vehicle, to the sensor, as well as to roadside area. Okay, so typical ITS contains all these components. But now, for you to have a real-time data exchange, we need the corresponding infrastructure control systems, so that the live information now can be shared depending on the traffic conditions. Okay, so therefore it is now possible to have the live incident detection and possible to adopt traffic signals. It means to say that depending on the traffic density, to automatically regulate the probably the timings of the traffic lights, traffic signals, and then streamline the traffic in the routes or in the lanes where there's less traffic. Okay, so apart from this, it is also possible to have fleet management, dynamic fleet management. That means to assign the vehicle movement between different places. Okay. Apart from this, we do have high-speed wireless networks, and then fiber optics, and then cloud platforms. Okay. So therefore, in all this, we get a nearly instantaneous response. Okay. So now to talk about, anyway, I don't think I have to spend more time because I already had a previous speaker given more details on this, but let me see what is there that I've included here. Okay, so it is now possible to have V2I, V2M, and V2P. In general, all together can be called as V2X. Especially, this is possible in 5G because safety is addressed here, and then crash prevention can be addressed, and then the routes can be optimized, and then we can have a very coordinated driving strategies among autonomous vehicles. That is possible only due to this one. Now, apart from this, it is also possible to handle the emergency vehicle priority, and then congestion, etc. Any kind of accidents or any kind of a sudden unexpected issues that one need to handle. In traditional systems, it would have taken a lot of time for the people to respond. But whereas once we have the intelligent transportation system, the reporting becomes pretty much faster, and then not only it becomes faster, but it becomes almost instantaneous without any manual intervention. Okay, of reporting of any such abnormality in the transportation system. Okay. Okay, so the infographic on the screen, just shows you various types of vehicle to anything is possible. Okay. But essential thing that one need to understand here is the capability of this communication happening without any issue, even when there are obstacles. So we have communication technology which support such kind of an exchange, even though there are obstacles, especially in the scenario that you are seeing on the screen, where there are 90-degree turns, and there are vehicles at 90 degrees to, if at all there is a need to communicate, the buildings at the corners will definitely obstruct. Okay, but how such communication is made possible? Okay. I think you have, sessions. I think you have tomorrow some sessions on, direction of arrival and then how VTX systems work. Okay, I will not go into technical detail, but I think the sessions are well planned. And towards the end of this FDP, you will have enough information on all kinds of technologies. You have a session on edge computing, and I think you have a session on simulation using NS3 software, and that's what I could see from your schedule. And then you do have, I think, a session on cybersecurity. Though I give you some information today, a brief introduction, but I think you have details on the architectures in upcoming sessions. And you also have AI/ML techniques for V2X, and I mean these things are, I think, each major aspect is being covered by, I think, one speaker in the upcoming sessions. Okay, all right. So the use cases for each of these three or four scenarios, if you see, I2V or V2I, whatever it is. Okay. The use cases includes adaptive traffic signal control, as I mentioned earlier. It can be accident and road work alert. Okay, road repairs or road work alerts, and then dynamic speed and lane guidance for improved safety, etc. Okay, I mean these are pretty much required as of now because of the requirements of urban transport, urban mobility. Okay. So therefore, the drivers can be guided well in advance. Okay, so that they can switch the lane instead of having a surprise down the line after traveling few kilometers. Suddenly, there's a traffic jam. Okay, so such thing can be informed to the drivers either manually through some kind of a dashboard or through some application, or it can be if it's an autonomous vehicle, the information comes automatically and then switches the lane immediately so that such traffic abnormalities can be avoided. Okay, this is one of the use cases of vehicle to infrastructure, where you have infrastructure already set up to gather this information and then essentially communicate this to you. Because while traveling on the road, next to you on the roadside, you have the roadside units which have all this information. So immediately it gives information to you because you are very close by. Okay, not only this, I mean, we can talk about so many things. Okay, let's say available parking places. Okay, and so that you don't have to search for a parking space once you reach the destination, and then possibly the information about the congestion at a mall, at a shopping mall, or at a movie theater, whatever it is. There are so many use cases. Very few are listed here, but there are so many use cases by which I2V technology can provide you. Okay, and similarly, when it comes to V2V, vehicle to vehicle, as mentioned a little while ago, it is possible to share information about the speed, and then information about location, and then the trajectory data supporting collision avoidance with the intelligent sensors mounted on the rear and front of the vehicle. And then, as I mentioned, cooperative lane changes. Of course, V2V, I mean, as I mentioned, all these are again integrated. Okay, it's not that all these are separate entities, but V2I or V2V or V2, P, they're all interconnected. So information available in one, vertical can be shared with other verticals as well. Okay, so cooperative lane and then predictive traffic management, etc., etc. So all these actually comes under V2V communication issues. Okay. So since we have the low latency as one of the major offers of the 5G, it is possible that accidents can be reduced, and then we can have advanced driving features. Okay, and then it is possible to manage the speeds adaptively by means of adaptive cruise control. Okay, of course, all this for autonomous vehicles, where it is possible to increase or reduce the speeds automatically. Otherwise, manually a driver has to apply brake, and then manage. Okay. So overall, V2V benefits include the road safety and then smooth traffic flow, reduced congestion, and then increased fuel efficiency. Okay. Increased fuel efficiency can be, linked to your, maybe shortcuts or changing routes, okay, or coordinate driving, whatever it is. Okay. So the infographic that is there on the screen, basically shows you some of all these use cases of V2P, V2V, and then V2I, or I2V, or I2I, various things. Okay. So these are all the various scenarios by which actually 5G can, make it possible to have all such communication without any flaw. Okay. So it's only in future. Of course, advanced countries have partial implementation of all this, but in future, I think this is going to be a dramatic, change that we're going to see in future. Okay. So now, next aspect that I want to talk is core applications. Core applications is autonomous vehicles and real-time decision making. So some of these features we have already seen. Which is now possible by means of the feature-rich 5G networks. Okay. And then, the hardware design and then the capabilities of the integrated the system that is embedded into the car electronics and its intelligent way of identifying the surroundings and then modifying its trajectory or a path, okay, through sensors and then, high precision cameras, all that is possible. So this is, one of the core applications in terms of real-time decision making. I think tomorrow, maybe in tomorrow's session or day after tomorrow, I don't remember, but I think we are going to see a separate session on AI ML use cases on V2X and then decision making, and as well as the object detection, various criteria. I think we have a separate technical session on this, so I will not divert myself into it, but I'll just mention that this is one of the core applications of this. So another core application is adaptive traffic management. I mean, earlier I mentioned this, but to understand more what actually it means is that we'll have the real-time updates to the central stations, okay, so that routing and rerouting can happen automatically. So these are final aspects, okay. Under adaptive traffic management, what all we can do is that there are many final issues that are automatically taken care of. Okay. It is all possible because of the IoT devices and then the vehicle telemetry and the enhanced throughput and the quick response. Okay. And apart from this, we have the 5G deployment possible in the case of buses, which are smart buses as well as the smart railways. Okay. Where again, the real-time vehicle tracking shown to the driver of the bus, and then they will get the information about the predictive maintenance and then route optimization. Okay, can made possible by the 5G networks. Okay. I mean, you see some overlap in what I am talking from the previous slides, but as I mentioned earlier, these are all interconnected with the various features that are integrated with this. Similarly, it is possible for the fleet operators to utilize AI and the 5G data for automated rescheduling. Depending on the end user's requirement, the resources can be allocated so that the entire system is aware of what is happening, and then the overall the efficiency can be maximized for urban mobility. Of course, maybe if I explain more details, then you will appreciate much better. But of course, it is beyond the scope of my talk to go into more details. since we already have detailed technical talks on some of these aspects. Okay, so then another case is emergency vehicle prioritization and safety. So therefore, it is possible to dedicate some communication channels on priority basis for the emergency vehicles like ambulances or VIP ambulances or VIP cars like ministers' cars or high designated officials. Okay, okay. So it is possible to dedicate some, or it is, if not dedicating permanently, but dynamically we can allocate the resources so that it is possible to quickly reorganize the routes for emergency vehicles. For example, if there is an ambulance, okay, or if there is, if not one ambulance, if there is a emergency medical care system, for example, for a organ transplant, let us say a particular ambulance is carrying a heart, okay, or kidneys or something, some major organs, okay, where time is very important for their reimplantation in the patient body. So therefore, in such cases, in all the cases, airlifting may not be possible to transport them through airplanes. So you have to use only road traffic. Okay, so only in such thing you have to appreciate how technology is helping in actually immediately preparing a green corridor. Okay, green corridor means that entire the traffic is diverted. Okay, for the ambulance which is carrying critical organs for implantation. Okay, so that's what actually we mean by emergency vehicle prioritization and safety. Okay, so such thing it's not simply not possible by manual traffic police or any kind of walkie-talkies people use. Okay, it is possible only at a global level, at a city level. Some intelligence should be there within the system, which can automatically warn the drivers to divert into a different route automatically with this information. That should happen automatically, not with very little manual intervention. Okay, so that is possible only by 5G. Okay, so I mean, all these things are very thrilling to understand and hear, and then but that is the future that we're going to live in. Okay, so that's what I explained called dynamic route clearing, and then real-time hazard warning, etc. Okay, ensure ambulances, fire stations, fire vehicles, police vehicles, and then VIP vehicles. Okay, so it's actually a life-saving innovation that we have, which actually 5G is offering us. Okay, which we have to appreciate, and thanks to 5G technology developers for such life-saving innovations. And similarly, integrated safety systems, which are into the V2X systems, like edge computing for instant alerts, which I mentioned earlier already, so that accident risk can be reduced during even emergency operations. For example, if there is suddenly if there is a terrorist attack, we don't know when such things happen, or if there is some kind of if not a terrorist attack, let us say there is a explosive, a bomb blast or something. Okay, so in such emergency situation, how quickly the entire thing has to be diverted. Okay, so if there's a bomb blast or a attack in some area, okay, all the drivers will have a surprise when they reach, and then finally they end up into a big kind of an issue. So if such things are known well in advance, and if the drivers can be informed much in advance, then they can be diverted in different routes. So that's what I'm saying. All these things look to be essential in the future. Then apart from these things, we have logistics and fleet management possible with 5G and AI transforming your fleet operations in various ways. Okay, so we have connected logistics hubs and vehicles, so they can use massive IoT and edge analytics to optimize the routes, schedule their delivery dates and times, and then the load can be allocated appropriately, and so that overall efficiency can be boosted, and then costs can be ultimately reduced. Okay, Yeah. And apart from this, you can have rerouting possible based on the traffic condition or weather condition or remote diagnostics so that the overall reliability can be improved. Okay. So therefore, AI is going to play a major role in the fleet management. Okay. So in fact, it is very tremendous. It's a separate subject matter altogether. I'm not sure whether you have a technical session on the fleet management. I don't know whether your schedule has this, but I think you have a V2X and then ITS in smart city and integration with urbanity talk on that. Maybe some aspects of fleet management are covered in the session. Okay. So this is going to be the future of the meaning of a fleet management and then appropriately, delivering goods and services to the people around. Okay. So another aspect of that I want to cover, major aspect is IoT and data integration. Okay. So IoT sensors for smart roads and highway. So when do you call road as a smart road? When do you call a highway as a smart highway? Okay. Only when you have the roadside units integrated with cameras, inductive loops, and then weather detectors. Okay. And then so on and so forth. Okay. So that the environment now can be updated and then the information can be passed on to the people who are trying to reach that destination, in real time. Okay. Uh, all kinds of, information can be given, whether it is a rain alert, whether it is a fog alert, where you have low visibility, or any kind of a disturbance by the people or by the system, any such thing. Okay. So all that is possible only when you have the IoT sensors integrated in the roadside units. Then we call it as a smart road or a smart highway. Okay. So therefore, this is an infographic which shows how the roadside units collect the information and then send the information to the vehicles. Okay. How IoT is revolutionizing the traffic management on the smart highways. Okay. And of course, this aspect I've already covered, edge computing for low latency decisions. Okay. As we mentioned, that we have the processors integrated to the IoT sensors, which have the capability, to process the data because data is generated there itself, and it can even be processed there itself. Okay. So all the signal timing, emergency event detection, remote diagnostics, and then delays, all that can be handled at a near instantaneous analysis can be done and can be updated to the drivers. Okay. So apart from this, we do have technologies like big data and then blockchain. Okay. All this is now integrated and we have the dedicated AI algorithms integrated into the traffic prediction. Okay. So the sensor readings and then mobility trace statistical traffic data now can be analyzed, and then based on the season, year, and the occasion. For example, rainy season or winter season where there's a heavy fog. Okay, so some of these statistics now can be updated because we have the history. Similarly, it can also be like festive seasons, for example, during festivals like Christmas and we have a heavy traffic like that, whatever it is, that we have historical traffic data by which, the AI system can infer and then give some hints that, if you are traveling on these dates, okay, it can hint you that, please plan in advance and you may have a traffic jam or some such things can be hinted to the, users, okay, that way. So AI algorithms essentially use this data to predict traffic density, identify emergency bottlenecks, and recommend the optimal routing or intervention strategies so that users don't have to worry much. Okay. So, of course, these things can also help decision making or for the policy planners, operators, and autonomous vehicle systems so that they can appropriately plan for the resources which are to be installed. And then cloud to edge intelligence in transportation, that is from the edge to the cloud. Ultimately, even though edge computing happens and then communication is happening, but ultimately there has to be somewhere some centralized location, okay, which is far. So the only way is actually that we need to have a very intelligent interface between the edge to the cloud or cloud to the edge. Okay. So therefore, the cloud platforms now can have some of these deep analytics softwares, and we can also have a long-term storage of the data, and then they can have several AI modeling and training algorithms. Okay. Such things there we can use cloud platforms. Okay. All right. So cloud to edge data flow now can actually allow automated and ultra reliable service in both urban and rural transport context. Okay. Apart from this, we do have digital twins for transport networks. Okay. Now, digital twinning, you know very well that we have digital twins for various purposes. For example, I can have a digital twin for a smart city road network. I can have a digital twin for a drainage system of a smart city. I can have a digital twin for the city infrastructure. Okay. So it means to say that on the computer we have digital twin. I think I have an infographic. I'll just show you. So this is an infographic of how digital twin works. Okay. So for example, I have the physical asset here. Okay, a physical asset as a process. So this entire thing has a digital twin with support of AI, which is a virtual model. So that means whatever happens here will exactly get reflected here. Okay. So therefore, it is possible to have a very huge data storage, which has information about all what is happening here. And then with the AI analytics here, and we can have visualization interfaces. So whatever is happening physically here, we can monitor through sensors and then see what is happening in the entire city. Okay. So therefore, one need not go physically there to verify what is happening there. If you go to the digital twin technology, then you will understand completely what is happening over there. That's why it is called digital twin of a physical, area, asset, or whatever it is. So therefore, we have a lot of optimization in terms of engineering and geographic information system, maintenance system, business networks, and financial thing. Okay. So this is called digital, twin. So such digital twin now can have even for the transportation system also. Okay. So the operators can have a digital twin of the entire city traffic network. Okay. Or for the countrywide traffic network, that where there are highways, how many lanes are there in highway, how many traffic signals are there, how many speed cameras are there, and how routes are being diverted by road unit, whatever it is. So therefore, we have the entire traffic system on your screen where you can see in real time what is happening at various places. Okay. All right. I mean, whatever kind of infographic that I shown you earlier, okay, I mean, something like this, okay, which can be, of course, this is a AI generated image. It's not a real image, but this is what actually we wanted to have in future, okay. So there's only a model that is showing you, though it is not in place, but this is what we aim at, okay. And this is really an intelligent transportation system with a smart, highway. Right. So the moment you have this means, you have all this is possible now, including digital twin for the kind of a network that I have shown. So digital twin supports because it actually gets all the data live from the IoT sensor streams and from the infrastructure and as well as from the vehicle. So entire thing is now available for you in a dashboard, and with a click of your mouse, you get information. You get everything about what is happening in the entire city. Okay, and that's why it's called digital twin. Okay, simulation, predictive maintenance, capacity planning, incident response, all that can be mirrored. Okay, whatever happening in the physical network at the digital twin with very high fidelity. This is one, advantage. Okay, I mean, maybe a digital twin may look something like this. Okay, so this is not a real video or a real photograph of a given, city scenario, but it is a simulated city environment, okay, where all these vehicles can be real, but they're not real photograph, real video of vehicle, but a vehicle simulated, which is a digital twin of your own vehicle, okay, where you got the data from the roadside units, okay. So therefore, if there is a simulation, like a video simulation of the same scenario, what you are seeing on the screen is played in front of you, I mean, it is as if like a real video is being shown to you, but in fact, it's not a real video, but it's a simulated scenario, current scenario of what is happening in the entire city. Okay, so that's possible only by digital twin that is being, enabled. Okay, so now I think I'm few slides away. I'll just quickly complete. Now, what next? What is beyond 5G? Okay, now 6G now promises ultra fast, ultra reliable connectivity. Of course, they are also fine, but ultra fast, ultra reliability, moving beyond 5G in speed in terms of latency integration. So therefore, now with 6G, it is possible to have from gigabits per second to terabits per second, and then latency decreasing from milliseconds to microsecond, okay, latency. This is a 6G, okay. 6G means gigabits to terabits, and then milliseconds to microseconds, and then we have all pervasive IoT device support. It's not just million, okay, but pervasive IoT means everywhere it is there. That's a meaning. That's what 6G is supposed to give us. So therefore, we have to wait and see what 6G, gives to. Okay, and we're all, waiting for 6G to make a reality. Maybe a few years down the line, possible. Okay, all right. So therefore, we have an advanced application. So some of the key technologies which are part of 6G, one is a terahertz band, okay, and then holographic connectivity, etc., okay, where it is possible now to have a communication possible with the full 3D communication, and then holographic connectivity is possible with different types of avatars, maps, spatial guidance, transforming traffic management, etc. Okay, so therefore, so all this is actually you would have seen in science fiction movies. Okay, now that can be reality in the 6G because we have an important aspect called integrated sensing in the environment. Integrated sensing and communication we have. That means some kind of a sixth sense technology also will be integrated into 6G. Okay, not normal communication, including sixth sense. Okay, so therefore there is something more kind of a thing. That's why it's called integrated sensing and communication. So therefore, we have the real-time environment awareness, precise localization, adaptive vehicle coordination. Okay. Of course, other than this, there are many more things what 6G is supposed to offer as per the subject experts. Okay, which we can't even imagine. Okay. All right. And then we have quantum networking and ultra intelligent connectivity is another aspect of 6G network, where we have quantum resistant cryptography to give more security, privacy, and reliability integrated. Okay, I'm sure I think you have a separate session on cyber security in connected vehicles. I've seen the title in your schedule. I think there more details of cyber security you will understand. Okay, so therefore ultra intelligent connectivity, predictive maintenance, remote diagnosis, all that is possible now by the quantum computing. Okay. And with such a quantum networking, it is possible. In fact, quantum networking is supposed to be the future of global communication. Okay, it's coming in a big way. Okay, and apart from this, we have anyway for environmental sustainability, we have green networks. That means low energy efficiency is one of the central themes of 6G. Okay, so that it's in align with the Sustainable Development Goals of United Nations. Okay, SDGs of United Nations. Then we have advanced energy management, environmental monitoring. Okay, all this will be part of your green energy networks and energy efficient mobility, which is provided by 6G. Of course, partly it is now being implemented in 5G, but in 6G as well as it takes. Okay, and apart from this, we do have, though I will not spend more time here, but that we have what is called Internet of, we have what is called Internet of Quantum Drones. Okay, which will actually help in managing the city network. Okay, since we have an issue managing roadside network, it is possible to have a swarm of drones, okay, flying above, okay, and then they can in turn, okay, cover more physical area and then help in communication. Okay, that is also going to be there in future. Okay, so that's what we call as a future-ready infrastructure for smart cities. Okay, future-ready infrastructure. Okay, either in terms of real-time digital twins with AI-driven management as convergence of 6G, IoT, and quantum networking makes all this is possible. Okay. Now, what is the societal and economic implications of this? all these technologies. Okay, what is the impact of 5G, economic impact of 5G and transport? Okay, economic impact means in terms of investment, in terms of money, what is the impact? The impact is supposed to be in terms of several, billions of dollars. Okay, it is estimated that, we will have about 280 billion by 2030. Okay, and then connected traffic infrastructure, supposed to, reduce the vehicle runs. Okay, because we are going to optimize. So there we are going to save a lot of money now. Similarly, real-time data also enables cost reduction in terms of cost reduction, fuel savings, minimizes delivery delays, etc., etc. Because this is an economic impact. What is it we're going to get? Okay. In fact, I have a lot of information to show you on the economic impact of 5G in terms of various applications. Let it be agriculture, let it be the entertainment, or let it be education, let it be financial, health, okay, hospitality, manufacturing, various things. Now everything gets impacted by 5G. Okay. It is because simply that 5G supports all this kind, autonomous trucks, advanced IoT tracking, augmented reality, video surveillance, so on and so forth. So the entire supply chain logistic industry gets impacted by the 5G technology. Okay. And coming to the jobs and skills for 5G mobility ecosystem. Now we know that we need 5G network engineers. Okay. There's a demand for 5G network engineers, IoT device specialists, AI model trainers. Okay. So therefore, there's a lot of scope for jobs and skills. Okay. So therefore, we have a demand for the advanced skilled manpower in data science, cybersecurity, machine learning, etc., etc. This is another thing. And similarly, we have sustainability addressed by this technology, by this intelligent transportation system, in terms of reducing carbon emissions, because no fuel vehicles, it's only electric vehicles that travel. Okay, so therefore that also can be. And policy and global trends. Okay, and at the global level, what kind of policies that you take in terms of investment, in terms of spectrum allocation, because regulations vary from country to country. Similarly, what is the readiness of ecosystem? What infrastructure to be deployed? Okay, all this actually influence the technology deployment. Okay, and we also have to see, we have to ensure the interoperability and security. Okay, as I mentioned again, the technology has to be aligned, and then regulations has to be common. Okay, all right. And then towards the end, what are the challenges and considerations that we have for all this to happen and to use 5G and beyond 5G technologies for intelligent transportation? What are the challenges? Okay, typical challenges, and how can we address them? Okay, one challenge is infrastructure cost and deployment barriers. Infrastructure cost means installing base stations and installing roadside units, and then installing the network itself. Okay, how much it costs? Okay, what is the typical rollout? Okay, so several $1 trillion it costs. Okay, in terms of procuring towers, though they are very small, in terms of procuring spectrum, optical fiber cable, edge computing devices, etc., etc. Okay, and then if at all you want to upgrade the existing 4G to 5G, it also costs a lot of things. Okay, so therefore, obviously, one challenge is the deployment cost. Okay, there is a very high deployment cost in terms of all this, in terms of towers, spectrum, fiber backhaul or backbone, edge computing. In terms of this is a challenge. So we have to see how these challenges can be met by the government. Similarly, data privacy and cybersecurity risk. Okay, this is always there. We have cybersecurity vulnerabilities to hacking. I think in tomorrow day after session, we have a cybersecurity session for the connected devices. There, I think you will learn more technical details. Okay, so that we're protecting data privacy is very critical now. So you need a good encryption. Now, as I mentioned earlier, it uses a quantum resistant cryptography as part of this. And then we do have advanced rapid threat detection and AI-driven algorithms so that your data privacy can be maintained. Okay, that is going to be another. And coming to the another challenge of spectrum allocation regulation, even here, it can cost operators a lot of money because you have to buy the spectrum for you to deploy 5G service. Okay, For example, Jio, Airtel, Bharti Airtel, there are so many. Now we have the 5G operators in our, country. Now all these operators, now they have to buy the spectrum, then only they can provide you 5G service. So it costs a lot of money. And then there are regulations. And then when it comes to interoperability with other countries, again, there are regulations. So there are regulatory disparities across the regions. Okay, this is another thing. We don't have a very uniform regulation for the entire world. Okay, depending on the country and their government and then government policies, some of the things change. So therefore, the frequency bands are different, licensing policy is different, deployment conditions are different. Okay, interoperability regulations are different. Okay, device standards are different. So all these are the challenges now. Okay, so therefore, government should have some kind of a facility to have all this. Okay. And then apart from this, we do have a very important challenge called ethical and safety consideration in AI-driven mobility. Okay. That means if something goes wrong, whom do you blame? Okay. If the accident happens, whom do you blame? See, if accident happens when a person is driving, okay, we can take an action on the person and then we can send him to jail. Okay. But if AI is driving the vehicle, if the accident happens, you can't now put a AI system in jail, right? Okay, so there is an ethical, regulation. Okay, now who is responsible now if something happens? Because everything is now AI only. Okay, so therefore AI algorithm should guide autonomous vehicles so that ethical principles are upheld. Okay, that means like how we see typically in our urban mobility, people take the drivers, the manual drivers I'm talking about. Okay, they just they just cross your way and then they do rash driving and then they don't follow the traffic rules. All this will happen. Okay, now it is quite possible that all that also happens in AI-driven systems. Okay, it is quite possible because they're all autonomous vehicle. Some hacker can hack your autonomous vehicle and then make it go haywire. Okay, without any control. Okay, because it's autonomous. Okay, hacker can make it just go haywire and then keep colliding with the sideway vehicles and then create a hue and cry and accident. It's quite possible, right? Okay, because the person can control, but it's an autonomous system. But what is the ethics here? How do you, how do you now address this ethical issue? Okay, how do you ensure transparency? How do you ensure accountability? Who is responsible for it? Okay, and then how fairness decision is taken. Okay, now all this is a big issue. Okay, right. So something like that. Fine. So I think I have come to the end of the session almost. Okay, future of the mobility, and there are some global case studies. I'll just share these slides. You can go through them anyway. It's already 9:30. Different countries how they are implementing, and in India how 5G smart highway project is going on. Okay, how the government and public and private agencies are working together so that network deployment can happen without any problem. And what are the lessons that we learned from early deployments? Okay, how government leadership and public-private partnership can work together to make this reality. Okay, how these standards can be noted. And in future, integration with smart city ecosystem. It's a holistic urban management that happens, mobility as a service, and future smart cities we will have. Okay, fine. And public-private innovation framework should be there now. It's not just possible only by the government. A lot of private parties should come forward to spend money, and then they should have a giant test beds and funding. And then, so there is a roadmap beyond 2030 on how much money to be spent to make all this happen. And ultimately, we have a vision for hyper-connected mobility possible once 6G also will be in place. Okay. So the final conclusion is now that intelligent transportation enabled 5G and beyond, it promises safer road congestion, reduced congestion, lower emission, and we need coordinated efforts to have this possible. And investment, policymakers coming, cybersecurity should be there, workforce deployment should come. So ultimately, beyond 2030 or 2037, 2040, we are going to have hyper-connected things. Okay. So thank you for your patience, and that's all from my side. maybe over to you for any small, queries.
So audience, any queries you can ask.
Yeah. Okay.
Sir, you have given a crisp idea about all this edge, cloud, AI, FG, and all.
Yeah,
Sir.
because my topic is an overview. It's not too
Yes.
technical. That's why I said this should have been the first session today,
Sir,
followed by several technical sessions. But yeah, please go ahead.
Yes, sir. Like, what is the specific feature as you have delivered in terms of communication, which makes us to look this V2X as more specific, sir?
No, that's what specific feature is in terms of see, V2X is actually a combination of all, right? V2X is actually a combination of communication from vehicle to infrastructure, or vehicle to person, or vehicle to pedestrian, or vehicle to vehicle, whatever. So in all the different types of communication, the specific feature is only a data exchange. Okay, how quickly we can exchange. I mean, ultimately, as a user, when I'm in vehicle, what is my requirement? What is my need? Okay. So my need is only my need depends on what I would like to do. Whether I want to exchange data with a pedestrian, or with another vehicle, or with the infrastructure, or with what? What is that I want to do? So therefore, this specific feature in terms of technology is that whatever I want to do, mainly data exchange or information gathering or information transfer, should happen, within no time. That's what I want. For
Sir,
it,
as you
yeah.
specified, like this massive memo, millimeter wave, and all, do you mean to say that as flip management or interdependency based on the application?
True, that's what, obviously. My only thing that I'm trying to drive it is that for all these, high-end applications, okay, we have the central or the core network is the same, okay, over which all these applications can run. So I don't get exactly your question of what specific feature. Are you saying specific application or what?
A specific feature only, sir. Like it is a combination of everything. So what it makes to be more peculiar?
See, what it makes peculiar is that the backbone itself is supporting all these high-end requirements of me as a user possibly quickly, right? If you want to ask me the specific feature of the technology, okay, the specific feature of the technology is the technology itself, as you mentioned, in terms of deploying technology, in terms of the hardware that we use for the technology. Let it be sensors, okay, high-speed sensors, or let it be the massive MIMO structures, or let it be the computing devices that we have, okay?
Yeah, got it, sir.
Yeah. Overall, this is a system which is actually making everything possible.
Yes, sir. Thank you, sir. Thank you.
Hello.
Audience, any other queries?
Hello.
Yeah, please.
Sir, can you tell about digital twin technology? Means, is there any simulation softwares available? And and one more question, sir. Means, is it specific software for specific case study, or it is very general? Means,
no, actually the software packages are general. Basically, for digital twin, we use actually virtual reality. So there are so many platforms on virtual reality. Okay, so these platforms are used. For example, if I want to build a digital twin for a road network, okay. What is required is that we will have the videos and then photographs of the entire area in front of us, and then integrate them into the virtual reality software. Okay. For example, there is a software called Unity. Unity is one popular virtual reality software. Using Unity, we can build a digital twin of the road network. Okay.
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 Sir, for smart city also we can use the same.
Exactly. Digital twin, developing a digital twin means we'll be using virtual reality software to have all the components of smart city available on your screen. Okay. For example, I'll give a very, in less time, I'll give one simple example. Let us say we have a municipal corporation. Okay. In municipal corporation, typically people find it very difficult, to handle issues like where the drainage is there, okay, where the potholes are there, and where the underground cables are going in, and where the optical fibers are going under the road. They will not have any idea. For example, if there is an issue of a pothole somewhere, people simply go and dig there. In the process, they may damage the underground electrical cables or optical fiber. They will not know what is there underground, right? So therefore, to handle this, if you have a digital twin of the city, okay, right? So if you want to do some repairs at a particular area, then what they will do, they will visit the digital twin and see what is there underground at that area, because you already have that in your digital twin.
Okay.
So therefore, now they will know if at all they want to dig at some place to address a drainage issue. Now they will understand in that area there are some optical fiber cables and there are some electrical cables going on. So then accordingly they can instruct the people, the labor people or whoever digging, that there are cables under this because they can't see them, right? But in a digital twin we can see all that. So typically digital twin, we have several layers of that we manage in a virtual reality, showing each and every component underground, okay, or underground or above the ground, whatever it is. Whatever you see in the physical world, that replica will be there in your digital twin model.
Okay. So we can say that it is a 99.99% means what we can say, the accurate one.
Exactly. Yes.
Okay.
It means to say that whatever you see anyway, you can see. Whatever you can't see underground can also be seen in digital twin.
Okay. Sir, if possible, can you share some links related, means more related to digital twin?
Yeah, sure.
One of the software you already mentioned, but
Unity,
other than that, if anything is, please.
Sure, definitely. What is your field of, what is your field?
Sir, my field is actually advanced communication technology. One new branch we have started. Under that, we are exploring the smart city and 5G technologies by using the case study like.
Oh, sure. Yeah, you can start actually, referring to some papers on, digital twins to start with, then digital twins smart city, and then try gathering some information. Then I also have some of my colleagues working on digital twins. I can give their contact and then you can talk to them and then do it. No problem.
Okay. Surely, sir, I will contact you. Thank you so much. Okay, thank you.
Shopna, madam, you can conclude, madam. Swapna,
yes, sir. Yes, sir. No more questions, right, sir? Done with the questions. Yeah. I request all the participants to fill the Google form. And also, that was a very insightful session, and sir has given so many valuable inputs. And our heartfelt thanks to Dr. L. Anjaneyulu sir for his valuable time. And also, I thank all the participants for today's who have attended 2 sessions. And I request all of you to keep participating actively for the next coming sessions also. And that's it. Thank you all. Thank you very much.
Yeah. Thank you so much.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir. It's really sessions. Thank you.